Hi guys, welcome to another chemistry video. This one is periodic table part 1. As you all know, this is the periodic table. There are a lot of letters and numbers that are on this table, and it's important for us to understand what all of those things mean. So we're going to be talking about those things in 2 video parts. We're going to start out just by talking about how elements are named. For some elements, the symbol is just the first letter of an element's name, like carbon. That makes a lot of sense. Same thing for oxygen, hydrogen, and sulfur. Other elements use the first letter plus one other letter. The first letter will always be capitalized, as you can see here in lead, copper, and gold. The second letter will be lowercase. In some elements, this makes a lot of sense, like aluminum is Al and platinum is Pt. For some elements, it doesn't make a whole lot of sense, like lead, copper, and gold, and that's because these elements are named for their Latin names. I talked about this a little bit in the last video, but it's important to know what is inside these different squares. The number at the top is the atomic number, which is also the number of electrons and protons. The number at the bottom is the atomic mass. If you round this number, you get the mass number, which remember is the number of protons plus neutrons. That's the mass number. So to find the neutrons, you just subtract the protons from the mass. And then, of course, here in the middle is the symbol. This is fluorine. Now let's talk about the actual periodic table. The first scientist to notice the relationship between the elements was this man. His name is Dmitri Mendeleev. He is a Russian scientist. He arranged a periodic table by atomic mass. He said the properties of unknown elements could be predicted by the properties of elements around the missing element. And he actually was able to predict the properties of aluminum using this method. Later on, it was discovered that the periodic nature of the elements was actually associated with atomic number and not mass. So what's really important is the number in the top corner, the number of protons. And then it's called a periodic table because periodic means patterns, and the elements are organized in a way that really makes sense when you know the properties of the different elements. Okay, so first let's talk about the groups. The groups are the columns on the periodic table. So right here is group 1, this is group 2, this is group 3, etc., all the way across the periodic table. The final group is group 18. That's here, the noble gases. We're going to talk more about these groups in part 2 of the periodic table video next week. The rows on the periodic table, so going straight across, are called periods. And there are 7 periods on the periodic table. The numbers of the periods just go straight down. So this is number 1, 2, 3, all the way down to the bottom. These right here are considered to be part of this section. They've actually fit into that section of the periodic table, but in order to make the diagram not so long, they're featured at the bottom of the table. The last thing we're going to talk about this week are the 3 different types of elements: metals, nonmetals, and metalloids. This periodic table shows you very well how these different types of elements are organized on the table. So on the left side, for the most part, are the metals. Most of the elements on the periodic table are metals. There is a nonmetal on the left side, and that's hydrogen. It's the only nonmetal on the left side of the table. The other nonmetals are here on the right in blue. And then there's the metalloids, which are these stair-step elements that are found right here in the middle. First, let's talk about metals. Metals are good conductors of electricity, good conductors of heat. They are shiny in appearance. They're malleable and ductile. So malleable means it can be hammered into shape without cracking. It can be molded or reshaped. And ductile means that it can be hammered or stretched into wire. So this is like aluminum foil or copper wire. Then they're also very dense, they have a high melting point, and they're also magnetic metals like iron and nickel. These are general properties of metals, but the actual individual metals vary. So some are better conductors than others, or some are more ductile than others. It just depends on the actual metal. Examples of metals are these elements here in red. Common ones that you are probably very familiar with are sodium, which is actually a metal in salt. I bet you didn't know that you were eating a metal. Right here, silver, Ag, platinum is PT right here, and aluminum foil is right here. All right, nonmetals. Nonmetals are found on the right side of the periodic table with the exception of hydrogen. They have properties that are the opposite of metals. So they're poor conductors of heat and electricity. They're not shiny, they're not malleable, and they're not ductile. They're not magnetic. Most nonmetals on the periodic table are gases, but there are some exceptions. So one is sulfur right here. And then also important, these nonmetals that are the noble gases. We'll talk more about them next time. And then finally, there are the metalloids. They're found touching this stair-step line on the periodic table. They're called metalloids because they have properties of both metals and nonmetals. There are very few of them. The most common one is silicon, which you might know that there's a place in California called Silicon Valley. A lot of computer chips are made out of silicon. It's also the second most common element in Earth's crust. All right, so next time we're going to talk about these specific families on the periodic table, the specific groups. Until then, make sure you do your discussion post, and I'll talk to you next week. Bye.